Hello and welcome to the Logos Research Associates live stream broadcast. I'm Dr. Sarah Buckland Reynolds, and it is my privilege to be your host for this presentation. My co-host, Mr. Jim Panplin, will likely be joining us later in this presentation, but I'm very enthusiastic to be a co-host for today's broadcast. Logos Research Associates is a fellowship of scholars and scientists that are committed to upholding a high view of science and a high view of scripture. We sincerely believe that scholarship, logic, and the scientific method should be used to show that the Bible's historical claims are both credible and ultimately superior to the secular model of origins. Logos sponsors many creation research initiatives and projects involving many different experts and scientific disciplines, all working towards the goal of increasing the explanatory power of the creation model of origins and of Earth history. Very, very important work. So as many of you who are no, this series is really to begin our presentation. We will open in a short prayer. So please, if you join me, let's pray. Dear Heavenly Father, we thank you for today. We thank you that you are in control of everything and all truth points to you, O Lord, no matter what discipline we are studying, no matter where we are in the world. We pray, O Lord, that your presence will be felt strongly in this presentation, that you bless our speaker, bless our co-host, bless the technology, O Lord, that we are depending on to bring this information. And above all, O Lord, I pray that everything done here will give you honor and glory, and that those who hear, O Lord, especially those who are not yet believers, will be convicted in their hearts to actually come and find you, O Lord, seek you with all their hearts and find you. We thank you for everything, and may your Holy Spirit intercede. In Jesus' holy and precious name, amen. All right, so now I have the pleasure of introducing our guest speaker, who is none other than Dr. Andrew Snelling. And Dr. Andrew Snelling obtained his PhD in geology from the University of Sydney, Australia. And he worked for a few years in exploration and mining industry and in mineral deposit research before working in full-time creation ministry and research since the late 1983, first with an Australian ministry, then with the Institute for Creation Research. Now he is with Answers in Genesis in the USA. Dr. Snelling was also the founding editor of what is now known as the Journal of Creation and was involved in the RATE project as a principal researcher and editor. He was the 6th ICC editor and was the founding editor of the Answers Research Journal. Welcome, Dr. Snelling. That's quite a background, and we really look forward to your presentation.
Good morning or good evening.
Yes, so joining from Australia time. So we will just have Dr. Snelling put up his PowerPoint so that we can see, and I can see your screen. And so we look forward to your presentation, Dr. Snelling.
Thank you for this opportunity to share with you on the significance of folds in the Tapeats Sandstone in the Grand Canyon. Back in 2017, this appeared in the Australian newspaper. It was on the front page. Oz creationists wins Canyon row. I had applied for a permit to collect samples in the Grand Canyon for research purposes, and I had to fight a lawsuit against the Park Service to obtain that permit and won. And it appeared on the front page of the Australian newspaper. You can see there I was in august company. President Trump at the time in his first term there was on the front page. So why was this such a big deal? Well, in case you haven't seen it, I want to share with you a brief video clip to introduce this research and its significance. We're coming up the drainage here of Carbon Creek. Got to go left and climb up this scree slope. where there's steps. The question we want to answer with this research was whether the sediments were still soft or had they hardened when the rocks were bent. You would expect if the folding took place 480 million years later, those rocks would have broken. They were brittle and they would have fractured and broken when they were bent, which isn't what we observe microscopically. So the only way to be able to investigate this is to actually take samples, look at the grains and the texture under the microscope. We can't find any detailed analysis of this rock layer in the literature. So it hasn't even been done. And you would think the Grand Canyon, of all places, the mecca of geologists, some of the basics haven't been done.
Well, it's just an interesting area that we want to try to sample. So we're going to take a sample right where this bed is kind of smeared up in here.
And so, yes, I have high hopes that this project will confirm that the layers were soft when they were bent, and therefore, because the whole sequence of layers had to be formed before the folding took place, it wasn't over 480 million years, it was only over the time span of the flood. As a Christian, I believe that God's word is a record, an eyewitness account of what happened, and therefore, as a scientist, I can expect that the evidence in God's world is going to confirm what we already read in his word. Well done.
Well, Andrew,
Here we are.
what do you have to say?
Well done, everyone. Fantastic trip.
So you can see that this was footage taken during the research trip, and I want to run you through the details so that you can get a picture of what the object of the research was, the goals, and then I want to present to you the findings of this research. Just focusing on the Tapeats Sandstone, here's a view from the south rim of the Grand Canyon, and here's a diagram, a geological diagram of the layers making up the walls of the Grand Canyon. And the layer that we want to focus on is the Tapeats Sandstone. It sits on an erosion surface called the Great Unconformity that most flood geologists believe was the erosion that began at the beginning of the flood, that eroded the pre-flood land surface and then started depositing the layers during the flood. And so here's the Tapeats Sandstone, the first of these units. The folds in question, there were 4 folds sampled, and 2 of them were one was in the Bright Angel, 1 was in the Muave, and 2 in the Tapeats. And we're going to focus in this presentation just on the Tapeats, but there is additional research results for those other folds and those other rock units. Now, the plateau through which the canyon is carved, the Kaibab Plateau, is currently greater than 7,000 feet above sea level. And so here we can see again this view from the south rim of the Grand Canyon. We can see in the canyon, there's the erosion surface. You can see the inner gorge there with the basement, crystalline basement rocks. There's the Tapeats Sandstone. And here we can see again up close the layering within the Tapeats Sandstone and that erosion surface called the Great Unconformity. And here further downstream, again, we can see at river level the Tapeats Sandstone, which of course enabled the sampling to take place. When we go downstream, we go progressively down through the layers on a raft trip, and we're able to sample the layers as we go down through the canyon. Here's a satellite image. You can see where Grand Canyon carves through a plateau. You can see the green there on the right. That's That's the forests and the Kaibab Plateau there. It stands out clearly. It's greater than 7,000 feet above sea level. And the interesting thing is that the canyon, you can see the Colorado River there on the right-hand side of the screen. It actually does a right-hand turn and carves its way through the canyon, through the plateau. It starts with the lower elevation to the right there, and it carves through that, which is an enigma for the secular views of how the canyon was carved. But that's another story for another day. At the edge of the Kaibab Plateau is the East Kaibab limestone, and that's where the layering has been folded. And here's a cross section to illustrate what we're talking about. On the left is the Kaibab Plateau with the sequence of horizontal layers. To the right, we go to the Marble Canyon platform, which is 3,000 feet lower in elevation, and you can see the layers have been bent. And we can see this in view. This is from the one of the eastern overlooks of the canyon. You can see the Kaibab Plateau there on the skyline and to the left, and then you can see the layers are bent and dipped down. And that bend down goes to 3,000 feet elevation there to the right, and that's called the East Kaibab monocline. Mono meaning one bend. Now, when we get into the details, when we get into where side canyons have carved through this East Kaibab monocline, such as in Carbon Canyon, we can see where layers like the Tapeats Sandstone have been bent, and they've been bent smoothly. You can see that the person for scale, and you can see that arrow, the bending of the layers there, the beds within the Tapeats Sandstone, and you can see the bending is quite smooth. Here's a close-up view. You can see if you trace any of these beds of sandstone, they bend their way smoothly. Yes, there's some fracturing, but they're not shattered. Here's another one of these folds further downstream, the Monument Fold, and that occurs within the plateau where the layers are above in the plateau. And so there's a number of these folds. And here's a map again. You can see the Carbon Canyon fold, CCF is arrowed there. You can see the Colorado River in black there. The red lines are the bends, and that's the one that's arrowed is East Kaibab lines, East Kaibab monocline. The Monument Fold, labelled MF, is on the Monument monocline within the Kaibab Plateau. Now, here's the problem, and let's outline this so you can understand what the problem is that we're investigating here. The Tapeats Sandstone was supposedly deposited 507 to 508 million years ago. That's been determined by detrital, zircon, uranium, lead dating. Then there's 10,000 feet of other sediment layers that were subsequently deposited on top of the Tapeats Sandstone over the next supposed 450 million years. We're talking conventionally here in the conventional timescale. Then all of those layers were uplifted to form the Kaibab Plateau about 550 to 60 million years ago. It's believed that the Farallon plate was subducted and pushed under and flattened under the North American plate as a consequence of it being flattened in its being pushed down. It actually pushed up because it was lighter material. It pushed up less dense material. It pushed up this plateau over a huge area, the whole Colorado Plateau, and the Kaibab Plateau is a subplateau within that system. So after 450 million years, all these layers should have been hardened. And so the rocks making up the layers within the Kaibab Plateau, when they were bent in these folds, should have shattered. Because after all, we know that hardened rock is like man-made concrete. And if you try to bend concrete, you know it will break, it will shatter. The only time that you can shape or bend concrete is when it's still wet and moist before the cement in the mixture has dried out and hardened. And so it is the same with rocks. They are they're deposited with the grains, then the water that's carrying them is trapped in between the sand grains. That carries chemicals, and then when the rock dries out, those chemicals precipitate and bind the rock together to make it hard. And so hardened rock will shatter. But here's the problem: the Tapeats sandstone has been bent in the Carbon Canyon and Monument Folds smoothly without shattering. We can see that again here. You can see in the hinge zone, the bend zone, that there's a nice smooth layering there in the Carbon Canyon Fold. Thus, we have to conclude it was still soft when it was bent in the folds. It was still bent and pliable, otherwise it would have shattered. Now, the only time the sandy layers would still be soft would be while they were still uncemented, when they were still wet, very soon after they were deposited. And we'll come to the other possibility in a moment. But when we think about it logically, soon after they were deposited, when they were still wet and moist, the layers would be soft enough to be bent. So the folding could not have occurred 450 million years after the sand layers were deposited and buried under these 10,000 feet of other layers, because the other layers pressing down, 10,000 feet of other layers, that's a lot of pressure, and it increases the temperature. It's going to dry out those layers. It's going to compress them. It's going to cause them to be hardened and cemented. And so when they were bent, they should have been shattered. However, the solution to this problem is if the sandstone was deposited in the first month of the biblical global flood cataclysm, only 4,500 or so years ago, and all the other layers were deposited during the following months, all very rapidly, and then the plateau was uplifted at the end of the flood year, then the Tapeats sandstone, less than a year after being deposited, was still wet and soft because those layers were still saturated during the flood. They would easily be bent in the folds without shattering. And since the sandstone was then bent smooth without shattering in these folds, the only solution is that the recent biblical global flood cataclysm during that year explains this observation. And that means that if the biblical solution is correct, the 500 million years never happened. And that's why this research was a huge problem to the evolutionary and old Earth geologists, which is why they stridently opposed this research project and worked hard behind the scenes to convince the National Park Service not to issue the research and sampling permit, which was why I had to file the lawsuit to overcome this worldview discrimination, and which was why when we showed this worldview discrimination in the lawsuit, it was easily won. Now, what is the rescuing device that the old Earth conventional geologists propose? Well, they say that since the Tapeats sandstone was buried under greater than 10,000 feet of other layers, that over 450 million years it was compressed and heated enough. After all, you've got the pressure from all those overlying layers, you've got the depth of burial. They say that it's going to be the pressure and it's going to generate enough heat to make the rock plastic and pliable like Play-Doh. And so they say the layers could then be bent smoothly without shattering. And as a consequence of that bending and the plasticity, the sand grains, of course, would glide past one another smoothly to facilitate that bending. And so they call that grain boundary sliding. And so the heat and the pressure would make the rocks plastic enough so that they would bend smoothly, but they would also potentially be metamorphosed, or if the temperatures were high enough, melt Well, they weren't high enough. They didn't melt, but they should have metamorphosed under that burial temperature and pressure, or so they claim. Now, we know that under heat and pressure, rocks do metamorphose. So down in the basement, crystalline basement rocks of the Grand Canyon, here we see the schists in the crystalline basement of the Grand Canyon. We can see a major smooth fold. Yes, under metamorphism at temperatures of 650 degrees Celsius, these layers will bend smoothly. They will be pliable and they'll be bent smoothly, but they're also metamorphosed. In other words, the rocks are changed from sedimentary rocks into metamorphic rocks with new minerals and new textures. And if the heat and pressure is high enough, then the rocks will actually melt. And we can see here where within the schists, we see pink granite veins where the schist has partially melted and produced granites. So we do know that that process can occur if the pressure and temperature is high enough. So the question is, was there enough heat and pressure generated by the burial of the Tapeats sandstone to make the rock pliable? So you can see some of the issues that we need to address with sampling and analysis of those samples in this research project. So here's the problem, their problem. If the Tapeats sandstone had been compressed and heated, the pressure and heat should have changed the minerals and textures in the sandstone, metamorphosed them. The sandstone would have metamorphosed with different minerals and the cement would have been recrystallized and some of the grains should have recrystallized. So, do we see such evidence of metamorphism of this sandstone? The issue is that no one had previously checked. There was no evidence in the literature of anyone collecting samples and examining them carefully under microscopes. There was no published research data about the Tapeats sandstone in the Grand Canyon. So, in a nutshell, here's the question. Was it deposition of the sand, followed by hardening to sandstone, then bending in these folds, all over 500 million years? Or was the sand deposited rapidly, bent in the fold, and then hardened to sandstone, all during the biblical recent global flood cataclysm, only about 4,500 years ago, all happening within a year or more, just over a year. So here was the research approach. Samples of the Tapeats sandstone were collected in the Carbon Canyon and Monument Folds, in the hinge zones, in the limb zones. So here's the Carbon Canyon fold again. And what we did is we selected beds, individual beds within the sandstone, and we traced them from the limbs through the hinge zones and out to the limbs. And we progressively collected samples through the limb and hinge zones of that bed. And here's another bed that we collected samples from the hinge zone and from the limb zones. The same happened in the Monument Fold, further downstream in the canyon. Here's the bend, and here's the layering. We can see where we had to collect because of burial by screed material. We had to break this into two sample zones, and so we see samples that were collected in these two zones, in the hinges and in the limb zones. And here's again in real life with the samples marked. And then we collected samples of the sandstone miles away for a comparison. You know, if the compression in the hinge zone of the fold had caused plasticity, did we see any difference in samples in the same beds collected away from these folds? And so again, here's a map of the canyon. We can see where the Carbon Canyon and Monument folds are, and we can see the brown stars show the samples that were collected miles away, still within the Tapeats Sandstone, but for comparison with samples taken from within the folds. And here's the satellite image again, so you can see where these folds are through the plateau and where the samples were collected distant from these folds. Here's regional sample number 1, collected just below 60 Mile formation, 60 Mile Rapid. And here's regional sample number 2. So the first objective was to demonstrate that the sand layers making up the Tapeats Sandstone could have been deposited rapidly under catastrophic conditions, that is, during the flood. After all, they would argue that Tapeats Sandstone took, well, 1 million or so years to deposit it conventionally. Within the flood year, it had to be deposited within days to weeks. And so we wanted to demonstrate, was there evidence within the sandstone that it was deposited under catastrophic conditions? And so we had to look at the details of the structuring of the layers and their fossil contents and document those with field observations and from the literature. And then all the sandstones would be subjected to X-ray diffraction by crushing to get their mineral analyses, then cut thin sections to examine them under petrological and scan electron microscopes to determine their mineral contents, their textures, the cement, and any signs of metamorphism. So here's the thin sections that were cut from these samples. And geologists know how to do this. You take a sample, you cut it with a diamond saw, you get a thin slice, you glue it to microscope slide, you grind it down till it's paper thin, 30 microns. You then can see the light will pass through the grains. You can put a cover slip on them, etc. Now, the arrows on those labels, by the way, when we carefully collected these samples, we put arrows on the samples themselves to indicate which was up, okay? The horizontal layers, but we have to indicate what is the top and bottom of the sample within the layers, and we can see that here in the thin sections. So up the top of the layers, and then you can see the layering within these thin sections. So we call that collecting oriented samples and recording the orientation so that we know exactly when we're looking under the microscope if the elongation of the grains parallels the bedding, the layering we can see on the macroscopic scale. And that was the case, of course, as you'll see in a moment. Now, what did we find? We found that there were boulders at the base of the Tapeats Sandstone, and the layering and the rest of it was consistent with what we know is produced by rapid hurricane or tsunami-driven transport and deposition of these sand layers. We've looked at how sand is deposited by hurricanes and tsunamis, and we can see the features that those events produce. And here we see the boulders at the base of the the Tapeats Sandstone, the hands there for scale. You can see how large these boulders are. In other places, some of these boulders are the size of cars, and we know that requires fast-moving, energetic water to move boulders that size. And then we can see the layering within the Tapeats Sandstone, commonly known as hummocky cross bedding, is typical of sands that are deposited by hurricane-driven water currents or by tsunami-driven water currents. And of course, during the flood, we'd have that. we'd have the tsunamis as a result of the massive earthquakes, with the fountains of the Great Deep breaking up, with the plate movements generating huge tsunami-driven water currents. And we can see evidence of that here in the layering in the sandstone. And then the fossils present within the Tapeats Sandstone are only transitory traces of trilobites, worms, and other invertebrates that are scurried across or burrowed into the surfaces hurriedly of the sandstone, and then it had to be buried rapidly to be preserved. I mean, here are trilobite crawling traces. How could those be preserved unless they were buried immediately after the trilobites made these traces? The same with these worm traces and these worm burrows, often called escape burrows. You can see the layering and they're U-shaped. The worms were burrowing down through the layering, and because of the rapid deposition, they realised that they were being their burrows were being covered up, so they did a U-turn. And even the conventional literature, these are called escape burrows. And so we have evidence from the fossils and the layering that the Tapeats Sandstone was deposited rapidly. Then the textures are made up of sand grains of all different sizes mixed together randomly, indicating the transport and deposition was so rapid there was no time for sorting of the grains. Okay, and so we can see this under the microscope. We can see large grains, we can see very large grains, we can see small and medium grains, all mixed up. In other words, the sand was relatively unsorted, which indicates rapid transport and deposition. And many of the grains are not very rounded, indicating the transport distance was short and the transport and deposition was so rapid, there was no time for complete rounding of the grains. Yes, some of them are rounded, but many of them are not. They are still poorly rounded, poorly sorted, and thrown together. And you can see this under the microscope. We can also see that the sandstone, while it's primarily made up of quartz grains, it also consistently contains significant quantities of potassium feldspar laths and grains, that is, crystals that are often not grounded or of different sizes. And so we can see that here. Here's a K feldspar lath, potassium feldspar lath that is partly rounded. Others are not so well rounded. And these feldspar grains are softer than quartz. So these observations indicate that the transport and deposition was extremely rapid. The transport distance was very short, and so erosion was very minimal. So it had to be eroded from the nearby underlying granites that contain the pink feldspars. And we can see that in the field. Some of the Tapeats Sandstone is actually deposited directly on top of the granites from which the sediment grains, these quartz grains and these potassium feldspar grains were obtained. The sandstone also contains abundant muscovite, that is, white mica flakes, and these mica flakes are made up of thin sheets. This is very surprising because muscovite is a very soft and fragile mineral. Quartz has a Mohs scale hardness of 7, where muscovite has a Mohs scale hardness of only about 2.5. So it's very soft, very fragile, and is easily destroyed by sediment transport. And this is seen today where in a desert, wind transport will actually obliterate muscovite flakes. Water transport will not so readily obliterate these muscovite flakes. And the muscovite is found in the sandstone as edge-on flakes between the quartz and K feldspar grains, usually aligned approximately parallel to the bedding Okay, so that indicates that this is a depositional feature. Here we can see one of those muscovite flakes wedged between quartz grains. Here we see another one of them wedged between quartz grains. And sometimes these edge-on muscovite flakes have split ends, where the thin sheets have been frayed and where they've been bent or broken. And so here we can see a muscovite flake wedged between quartz grains where it's been bent and where in a pore space the sheets have been split open at the end. Here's another example where the muscovite flake has actually been bent and broken and it's wedged between potassium feldspar and quartz grains. This means that the grains, the flakes of muscovite that we're seeing now had to be detrital. That is, the grains that we're seeing now, still in the sandstone, were among the sandy sediment grains that were very rapidly transported only a very short distance and deposited in the sand layers before these soft flakes could have been destroyed. In other words, we're still seeing the original detrital grains. These grains are not a result of any metamorphism after deposition of the sand grains. Furthermore, we find the cement binding the grains together is primarily quartz, that is silica, as overgrowths on the ubiquitous detrital quartz grains. And so here I've marked for you with red asterisks, you can see the cement between the quartz grains. Now the quartz grains, you can see these black outlines, that's the dust that was originally around the detrital sand grains. And you can see the clear quartz cement that has grown on top of those detrital quartz grains to bind them together. What's that blue material? Well, when the sandstone samples were prepared for thin section preparation, they were impregnated with epoxy resin under pressure so that when we cut them in a diamond saw, it didn't disturb the grain positions. And that epoxy had a blue dye in it. So any blue dyed epoxy filled the pore spaces so that we could also estimate the porosity. And that was very important. So those blue spaces, blue areas are the pore spaces. You can see the quartz cement has grown into the pore spaces. So, for example, in the upper right-hand corner, you can actually see in the pore spaces nice, smooth grain boundaries in the cement that are crystals. And you'll see that in a moment in scanning electron microscope imaging. Here's another example. You can see the outline, the black outline of the rounded detrital grains, and you can see the quartz cement that grew into the pore spaces to bind these grains together. And you can see that the cement has not been disturbed. The pore spaces are there. Remembering, if the rock was hardened first with the cement and then bent, that cement should have been shattered and those pore spaces should have collapsed. But we don't see that. The quartz cement is always intact. It is still pristine. It hasn't been disturbed or shattered since it grew around the detrital grains. And it cemented them together to form the hard sandstone with similar porosities in all samples. So here we can see on the left, regional sample 4 compared with Carbon Canyon fold sample from the hinge. And you can see from the blue areas that the porosity is similar. The sample miles away and the sample from the fold and the hinge where there was maximum pressure from the bending. It hasn't been disturbed. The cement is still pristine. The quartz, the porosity is still there. And so here we can see the estimated porosities. Regional sample number 3, over 5% porosity. We go to the Carbon Canyon fold in the hinge, 5% porosity, a limb sample approximately 4% porosity. And so the bending has not changed the porosity in the samples, the original porosity from sedimentation. So here, for example, we're looking at here samples 9, 10, and 11 from the Carbon Canyon Fold, limb, hinge, limb, 1.5% porosity, 5% porosity, 4% porosity. Here they are in the field. You can see where they sit with regard to the bend zone in this fold. Here they are compared to sample 3, which was on that chart. And you can see the blue areas. Yes, the limb zone sample number 9 has less blue areas, less porosity. But the hinge and the limb samples 10 and 11 is much the same as regional sample number 3. In other words, regionally and within the fold, the sandstone has experienced similar conditions. In other words, the folding caused no difference in the conditions the sandstone was subjected to miles away. And that is an important observation, because if it was bending under heat and pressure, then there would be differences in the hinge zones of the folds compared to samples miles away. Sometimes the rock fabric became a solid mass. In other words, there was so much cementation that the pores were completely infilled so that the quartz grains were tightly interlocked by the cement, and the grains became indistinguishable, so there were no pore spaces left. And so here we can see how the grains were entirely interlocked. Now, if cementation occurred before folding, what would happen when the folding occurred? That's been fractured and shattered. Or if it was plastic, it would have still been deformed, and the grains would have been deformed. And we've seen evidence under the microscope of that deformation. Here's another example how these grains are so interlocked and so cemented, they're just a solid mass. And so if the rock had been bent after the cement had been set hard, then the cemented quartz grains should have shown signs of having been shattered and or broken and then re-cemented. But what we see under the microscopes, plural, there is no evidence of that having happened at all. Furthermore, there is no evidence of any metamorphic changes to the sandstone or its constituent minerals, that is, the quartz, the feldspar, the muscovite, either in the folds, no changes in the folds, in the hinge or limb zones, or in the samples taken miles away from these folds. So here we can see no shattering of the sand grains, hinge zone sample number 11 from the Carbon Canyon Fold. The muscovite flakes show no signs of metamorphism, nor do the feldspar grains. They show only evidence that they are still in their detrital condition. They have not suffered from heat, pressure, and deformation. And here again, see, here's a limb zone sample 11. There it is there in the field. Let's look at hinge zone number 10, right there from the Carbon Canyon Fold. I mean, look at on the right, you can see the muscovite flake with the frayed edges. That occurred as a result of the detrital transport. You can see the pore spaces there, still there, all the blue colouring there, indicating the pore spaces. So the detrital conditions are still there. There's no signs of any metamorphism. There's no shattering and re-cementing of the quartz grains, no metamorphism of the feldspar or the muscovite grains either. And furthermore, there's no evidence of any grain boundary sliding. In other words, the quartz grains didn't move next to one another. And if there was any pressure to deform the quartz grains, there should be what we call undulose extinction. That is, under cross-polarized light, you should see wavy extinction or wavy colouring. And that should be present if the claimed ductile, that is, under heat and pressure, plasticity, deformation, had taken place slowly over the claimed millions of years under the presumed applied pressures and temperatures. So here we see in ordinary light of these two examples, a hinge zone sample of the Carbon Canyon Fold on the right, original sample on the left, and you can see they're exactly the same. You can see the original detrital grains, you can see the cement, you can see pore spaces. There's no evidence of the grains having moved relative to one another due to any ductile, that is, plastic deformation. And here we see two samples, a regional compared to a hinge zone sample, the Carbon Canyon Fold, under cross polars. There's no undulose extinction. In other words, the light colouring, the colouring of these grains is uniform. It's not undulose. It doesn't change across those boundaries, across those grains. So that indicates these sand grains were not stressed as a result of the bending. It wasn't plastic deformation, because under plastic deformation, the sand grains would have been plastic and they would have deformed, and you would see that with the undulose extinction. No, these sand grains were not deformed as a result of this bending. That means the grains were still in their detrital condition when bent. The sand was still wet and soft. Furthermore, detailed high magnification scan electron microscope images were obtained to look at the quartz cement in samples in the folds, both hinge and limb zone samples. And so here we see hinge zone sample 2 and limb zone sample 8 from this bed that we traced through the fold. Okay, here under the scan electron microscope, we see the pristine crystals of the quartz cement. Very well illustrated on the left. You can see the planar crystal faces and the terminal points of the crystals that have grown. You can see it on the right-hand side in the limb zone fold, just under the word crystals. You can see a termination, a nice termination with a flat crystal boundary. I mean, that means the cement hasn't been shattered. It grew as the last part of the process of the history of this sample. And so here's samples now 10 and 11 in the Carbon Canyon Fold. Let's look at them under the scan electron microscope. Look at these beautiful terminated crystals in the limb zone sample. And yet we can see similar ones, not as pronounced, but you can still see terminations and flat crystal surfaces in the cement in the hinge zone of the fold. Let's look at the Monument Fold for a comparison. We've been looking at the Carbon Canyon Fold. Now let's look at samples from the Monument Fold. Let's look at Monument Fold samples 1 and 3, a limb zone and a hinge zone sample. Again, look at the quartz cement. It's pristine. We can see crystal faces. We can see terminations on the crystals where they've grown into the pore spaces. Compare hinge zone and sample 5 with limb zone sample 7. Again, quartz cement crystals have pristine faces and terminations as the crystals grew into the pores within the sandstone. And then we looked at samples miles away from the folds. Were they any different? Was cement any different? No. Let's look at these distant samples. Number 1, look at the beautiful cement crystals, quartz cement crystals in 1 and 2. and 3 nice crystal faces and terminations, the same miles away from the folds as samples within the hinge zones and the limb zones of these folds. The cement is still pristine with terminations and faces from the cement having grown into the pore spaces. This should not be the case if the sandstone, after the cement was formed, had been bent millions of years later. Now, furthermore, we have other evidence about the temperatures and pressures this sandstone was subjected to under the 10,000 feet of overlying layers. We find in the crystalline basement rocks beneath the Tapeats sandstone radiohalos. And here we see examples of those in the Vishnu schist, which is part of the metamorphic crystalline basement rocks underneath the Tapeats sandstone. I've just recently published a paper on these radiohalos, but we know from the literature and from experiments that these radiohalos would be obliterated, they would fade and disappear if they had been subjected to temperatures above 150 degrees C after they were formed. And the fact that they're still observable means that since the radiohalos formed, the rock hasn't been subjected to temperatures above 150 degrees C. And then we find fission tracks in quartz grains within the Tapeats sandstone and within zircon grains within the Tapeats sandstone. Here's these fission tracks in samples from a limb zone Tapeats sandstone sample in the Carbon Canyon Fold. And here we see them from zircons collected from a tuff sample, a volcanic ash bed within the Tapeats sandstone, and the fission tracks within the zircons. What does this mean? Well, we know again that if there had been elevated temperatures in the Tapeats sandstone, these fission tracks, where the uranium atoms split due to fission, would have been annealed or obliterated. In other words, the damage to the crystalline structure, the heat would have caused the crystals the atoms to vibrate sufficiently that they would regroup back into the pristine condition of the zircon grains and the quartz grains. They would have been obliterated. And then we can look at the illite smectite content of the Tapeats sandstones. These are clay minerals within the Tapeats sandstone. And we know from the illite smectite ratio that they are a temperature and depth indicator of burial. And that's well known from the literature, well established from looking at petroleum, oil drilling samples. And so we're looking at Tapeats sample here, number 1, that was looked at the clay mineral content and the ratio. You can see the depth of burial and the temperature, corresponding temperature, was less than 30 degrees at a depth of just over 5,500 meters. So all this evidence indicates that the Tapeats sandstone never had burial temperatures exceeding 130 to 150 degrees C. 3 different lines of evidence that correspond to one another, and that's below the threshold for even the lowest grade of metamorphism. And so based on this evidence, we wouldn't expect to find any evidence of metamorphism of these sandstone, and that's exactly what we see. We don't see any evidence of metamorphism. We still see the pristine condition of these Tapeats samples. So, conclusions. All the observational evidence absolutely does not support the folding of the Tapeats sandstone 450 million years after it was cemented. It is overwhelmingly consistent with the rapid, catastrophic deposition of the sand layers at the beginning of the biblical global flood cataclysm year only 4,500 years ago or so. Then the bending of the still wet and soft layers occurred when the plateau was uplifted only 12 months later at the end of the flood year. And then cementing of the sand layers occurred after the sand dried out. The flood waters drained off the uplifted plateau. The sand layers dried out. The cement crystallized. The sandstone hardened. It dried and hardened at the end of and after the flood year. And if that's the case, if all of it happened within the flood year, only 4,500 years ago, then the 400 million years of supposed geological time for the deposition of all the layers and all that geological history are eliminated. So, in a nutshell, was it deposition of the sand, hardening to sandstone and then bending in the fold over 500 million years? No. It was, in fact, deposition of the sand rapidly at the beginning of the flood year, bending of the fold at the end of the flood year, only months later, and then hardening of the sandstone as the waters drained off and the sand layers dried out and the cement hardened as a consequence of the cement crystallizing, all within the flood year, only about 4,500 years ago. Well, publications for follow-up. The results were all published in the Answers Research Journal. So back in 2021, the first paper was published on the Tapeats Sandstone. That was designed to show that the sandstone was deposited rapidly. Here's the paper. You can look it up online, the paper and the appendices. Then there were papers published on the Carbon Canyon Fold. Here it is in the Answers Research Journal. The main paper and the appendices all available online, free access. And the Monument Fold was also published, paper on that with appendices, all available in the Answers Research Journal. There are also papers published on the Bright Angel Shale, the Muave Limestone, to show that they were rapidly deposited, and papers on the Mat-Cat Amoeba Fold in the Muave Limestone and the Whitmore Fold, the Whitmore Helipad Fold in the Bright Angel Shale. So there were 7 papers overall, Answers Research Journal papers for Fold, and a lay article was written about the legal battle and the lawsuit to get the sampling and research permit. You can read about that in Answers magazine. That article is available online. The fight for 53 rock samples. So all of this is available in the open literature, freely available and downloadable. And a documentary was produced because we had a videographer with us on the Grand Canyon research trip. That was because the lawyers realised that we needed to record what happened in the canyon lest we be accused of violating the Park Service rules. And so it was easy to take that footage and do subsequent footage of work in the lab and the results, etc. And that is available in the documentary, Is Genesis History Mountains After the Flood? And some of you may have already seen that documentary. In closing, I need to acknowledge that these samples were collected under a National Park Service research and sampling permit. And also the research trip was facilitated by a special use permit granted by the Park Service. There were donors who made the research possible. The AIG leadership supported and encouraged the research. The Alliance Defending Freedom conducted the lawsuit that enabled the permit to be obtained. Tom Vale of Canyon Ministries outfitted and led the research trip. You saw him on that video clip. Dr. John Whitmore, my colleague, Senior Professor of Geology at Cedarville University, he assisted on the research trip. You saw him in that that video clip. Ray Strom of Calgary Rock and Mineral Material Services helped with the laboratory and analytical work and had professional insights. And it's with great sadness I need to tell you that just a couple of days ago, our dear friend and colleague Ray Strom passed away. as a result of a battle with pancreatic cancer. Pray for his dear wife, Lois, and the funeral service coming up on June 1. Ray did a lot of work behind the scenes. He was an incredible support to this research, and his efforts need to be acknowledged. And of course, the peer reviewers that helped in checking this research to make sure that there were no glitches in my writing up of this research. So thank you very much. And it's back to you for questions and answers to come to follow.
Wow. Thank you so much, Dr. Snelling, for sharing these interesting findings and also interspersing your story. I can say the presentation was very scintillating. The photographs as well were very breathtaking. I can actually see our audience is already teeming with questions for you, but we do acknowledge for those who have not yet posed their questions, please do place them in the chat and we'll try to get as many of them as possible. So I'll just begin quickly with a personal question, right? So you started out the presentation with some of your story. You mentioned for Worldview decide to critique your research on these rock units and folds?
Yes.
And how did you deal with them?
Well, what happened is I agree with the process of applying for a research permit because they have to protect the integrity of the park. We can't have people just willy-nilly going everywhere. They could damage archaeological sites and cause pollution and all the rest of degradation. And so I agree with that. And I had put in the proposal, I had all the parameters and explained everything and had it peer reviewed before submission. Well, the Park Service sent it out for peer review and they sent it to conventional geologists. Of course, I'm well known in the scientific community as a creationist. Yeah. And so they sent emails to the Park Service saying I shouldn't get the permit. And they Park Service communicated to me, rejected the application, but with flimsy excuses. So we knew that there was something going on behind the scenes. The Alliance Defending Freedom got involved. They did a Freedom of Information search and got all the email correspondence between those conventional peer reviewers and the Park Service and found that the only main reason that they disputed my having the sampling permit was because I was a creationist and I shouldn't be allowed to sample in the park. And so it was obviously a slam dunk. There were a few small scientific issues that I dealt with when I reapplied. Again, the permit was rejected, even though they said it had good scientific credentials, etc. So in the end, we had to launch the lawsuit. Appended to the lawsuit was all the backstory with all the correspondence that showed the worldview discrimination. Well, wasn't only the superintendent of the Grand Canyon National Park that was subject to the lawsuit, it was her boss, the regional superintendent. It was also the secretary of the Department of the Interior. And so the lawyers that got involved, the Justice Department, the Park Service, when they saw that the scientific merit wasn't under question, but it was a worldview issue, they immediately said, okay, how can we settle this issue? And we said, well, just grant the research permit. They were expecting, we'd want a financial remuneration. We said, no, we're just interested in doing the research. And so within 6 weeks of the lawsuit being filed, the Park Service had caved in. And so within weeks, we had the permit to not only do the sampling, but also to have a research trip. You need a special use permit to actually do a raft trip just for research through the canyon. And we had all that involved in place. And so within a few weeks, we were able to do the lawsuit being settled, we were able to do the research trip through the canyon. And so that was the story. It took holding the Park Service feet to the fire for discrimination to actually get the research permit to do the research.
Well, I'm very happy you eventually got through, and I do connect a lot with your story. Well, I'll just quickly share. When I used to lecture as a secular university, I had a former colleague who saw me with a creation science book and said, if I believe the content of these books, I'm not fit to be a lecturer. So what I want to ask you then, following up, and then we'll get to our audience, what advice do you have for upcoming Christian scientists, let's say early career Christian scientists, in the face of hostility in academia?
Well, unfortunately, when I went through, it wasn't such a public issue. Back when I was doing my research for my PhD at the end of the 1970s, early 80s, it wasn't such a public issue. However, my supervisor did find out that I was a creationist, and he warned me to keep silent.
Yeah.
And so that's the problem. Unfortunately, those of you who are trying to get into graduate school, you need to keep your creationist belief under wraps. And unfortunately, that means sometimes you can't be involved in creation research until after you graduate, or you have to use a pseudonym and make sure that you keep below the radar. And it is possible. And I mean, it's not being deceitful. It's just being wise. Don't divulge that you're a creationist. Just go by your birth name in graduate school. And if you're involved in talking to other creationists, use a pen name and keep that under wraps. I know that sounds draconian, but tragedy is that's the way it is. I mean, you can get your PhD, for example, in a Christian university. There's very few that provide PhDs, but quite frankly, to have a robust qualification, it's good to go to a secular university,
Right.
In the field of your chosen discipline. I often say to students, if you've got a particular area that you want to research in, look in the literature as to who is publishing in that area, because that means they're at the cutting edge of research. Who is doing the most publishing in that area, and apply to go to their school and get them to supervise you doing your research, because that means that you're dealing with a researcher who's at the cutting edge, and that means you have to keep your creationist credentials under wraps. And then after graduation, there'll be time and place for you to have the opportunity to make this a public stand. But unfortunately, if you don't, you will get discriminated against, and you'll be exposed. I mean, there are others have had similar experiences. That some were more open about their position and didn't suffer the discrimination. I mean, Dr. Kurt Wise, who studied under Stephen Gould, his first graduate school supervisor when he did his MS, Dr. David Ralph, knew he was a creationist, and knew he was a creationist when he applied to go to Harvard. And Stephen Gould found out after a year that he was a creationist. It meant that there was greater scrutiny, but some guys like David Ralph and Stephen Gould have a high enough profile that they're not going to be bothered by having a creationist student. They're just going to watch him like a hawk and make sure he measures up to standard. Whereas other conventional scientists, unfortunately, feel threatened, and they will discriminate against creationists. So one has to be as wise as serpents and harmless as doves. And there's no set formula that fits all. You have to, and I would encourage you need good family support. You need good church support, people praying for you and supporting you, and you need academic mentors. So get to know other creation scientists and get them to work with you and pray with you mentor you and stand alongside you as you go through this process. They
Yes.
will give you advice as to when and how you should reveal that you're a creationist. They will help you. So not one size fits all, but you need people around you. You cannot survive alone. You need mentors, and I stress that. And there are mentors that are available, for example, through Logos Research Associates, through the Creation Geology Society, through the Creation Research Society. There are abundant ways of networking with non-public creation scientists to be mentored by them in the field that you want to study. So that would be my advice.
Thank you so much for that comprehensive answer. I really appreciate it. All right, so our audience has several more technical questions. This question was partially responded to already by an audience member, but he says, I was wondering about liquefaction. When occurring today, what liquefaction does to harden sedimentary layers from the past? Do they soften and reshape? Does that make sense?
Yeah, well, liquefaction is when the soft sediment, the wet sediment, is shaken and it becomes liquid. So a hard sandstone layer doesn't liquefy when it's shaken by an earthquake. So, for example, it happened in Christchurch when they had the earthquake there, and it's happened, for example, in Newcastle, Australia, where they had an earthquake, where there were still soft sediments, alluvial sediments in river channels, old river channels, that was liquefied and moved around, so the buildings built on those just collapsed. But the hardened rock layers beyond the old river channels didn't liquefy, and so the structures built on them, sure, they were cracked, but they didn't collapse. And so, no, liquefaction does not affect hardened sedimentary layers from the past. They don't soften and reshape. And it's only already softened wet material that's going to be reshaped as a consequence of liquefaction as a result of earthquakes.
All right, thank you for that. We have a question that's in multiple parts, so let me just try and go through it. All right, what we see throughout the tapeats seem to be consistent with Dr. Austin's current speeds. However, just for the Grand Canyon area, it would take over 100 years to deposit the tapeats at those speeds. I was wondering if it would have been better for you to show that the tapeats contain fasces, indicating deposition at a rate somewhere around 10,000 times as great as what Austin's current speeds could deliver, which is what would be needed to deposit the 16,000 foot thick Colorado Plateau at the required rate of 75 vertical feet per day during the flood. You can let me know if I need to go back through parts of the question.
That's all right. I can see who the questioner is. It's Tim Hebel of an old Earth geologist colleague, Tim. I didn't have time to go into all those details. You can go to the paper I wrote on the Tapeats Sandstone. Yes, I didn't go into all the quantification like Steve Austin did, but the evidence indicates from the hummocky cross-bedding within the Tapeats Sandstone that the cross-bedding is similar to what you see in hurricane deposition, tsunami deposition, and the speeds there are adequate for rapid deposition of the Tapeats Sandstone. And yes, it seems a big ask to have that required rate of sedimentation, but when you see for example, the ephemeral fossil material markings having to be buried rapidly, otherwise they wouldn't be preserved, and they occur multiple bedding surfaces throughout the Tapeats Sandstone, throughout the Bright Angel Shale, even higher up through the sequence. You see them all through the Grand Canyon sequence and beyond. Then it's not inconceivable that you would have this rapid deposition. And so Yes, Steve Austin has done one calculation, but those calculations can be updated with further work based on the layering that we see in the Tapeats sandstone, and that's a subject for further research.
All right. Could you remind us where the person who's asked can get more information again?
Yes, we could go to, for example, he refers to Austin's work. You can go to Steve Austin's book, Grand Canyon, Monument to Catastrophe, that was published by ICR in 1994. And then there's my Answers Research Journal paper, which I referred to in the presentation. In the Answers Research Journal, just go online to Answers in Genesis, go to the Answers Research Journal website, and you will put in Tapeats Sandstone, you'll find the paper there, published in 2021.
Okay, thank you so much. All right, this other question makes a claim that the metamorphism is a bit of a straw man because conventional geologists don't believe that the tapeats have been metamorphosed. What would you say to that?
Yeah, I'd agree with Stephen Mitchell because he's written a critique of my work, which was published online at the Peaceful Science website, and I've responded to those articles by Stephen Mitchell and his colleague. They're available on the Answers in Genesis website. It's not a straw man because, quite frankly, to have ductile deformation does require elevated temperatures and pressures. And it was important to show that in the research that the sand grains, the quartz, the feldspar, and the muscovite grains were still in their detrital condition. The cement was still pristine. It had grown into the pore spaces, and it had not been affected by any ductile deformation. There was no undulose extinction. All the features, you can go to the textbooks on this ductile deformation that Stephen Mitchell and others claimed conventionally has occurred, and you'll find that's what I did. I went to the textbooks and I looked at the features that they illustrated there and compared it with the features I was looking under the microscope at and taking photographs of, and they don't compare. So that means that ductile deformation didn't occur. And so it's not a straw man when ductile deformation, as proposed conventionally, yes, it wasn't metamorphism, but still heat and pressure enough to produce ductile deformation over millions of years, should have produced those kinds of features, and they're not present in the sandstone. It would have compressed the pore spaces. It would have affected the cement, and we don't see that in the sandstone, as demonstrated by the optical microscope and the scan electron microscope evidence. So all of that I've documented in these papers, and also referred to in the articles I wrote to respond to Stephen Mitchell's web articles critiquing this research.
Thank you for that. He does have a follow-up question. Are you saying that tectonic stress applied over a long time will produce metamorphism?
Tectonic stress over a long period of time will produce dynamic metamorphism. Yes, okay. That's well known in the literature. Slow metamorphism over millions of years of stress will produce ductile features, deformation. That's documented in the literature. And the question is that evident in this sandstone? Did this sandstone, was it affected by that kind of process? And the answer is the observational evidence says no.
All right. Thank you for that. If someone asks about the 75 vertical feet per day, what evidence do you have that the tapeats were deposited at that rate? What evidences would you provide?
Well, I mentioned those briefly in the presentation, and they're documented more so in the papers. There's the cross bedding, the hummocky cross bedding, the layering in the sandstone, indicating high flow regime. that would be equivalent to hurricane and tsunami-driven water currents, which are at speeds that are capable of carrying lots of sand very, very rapidly. And we have to remember that the Tapeats Sandstone can be traced right across the North American continent. We're not talking about a localized process. We're talking about a continental scale process right across the continent. And then there's the ephemeral markings from trilobite trails, worm trails, worm burrows, those of invertebrates trails and escape burrows. None of those features will be preserved unless, I mean, the creature has to leave those trails, and within hours they have to be buried. Otherwise, they don't get preserved. I mean, you can look in the real world today that any trails left on a sediment surface will get rapidly obliterated unless sand is deposited on top of them or sediment is deposited on top of them quickly to preserve them. And so that's the kind of evidence that I present in those papers.
Right. Thank you for elaborating. In this CRSQ article, Mississippian and Cambrian strata interbedding, 200 million years hiatus in question, William Weisgerber, George Ho, and Emmett Williams found interbedding at an unconformity. Has anyone else verified this anomaly?
Not to my knowledge. You're talking about the interbedding between the Redwall limestone and the Muave limestone on the North Kaibab Trail. That was documented in their CRSQ article. As far as I'm aware, no one has done further work on that situation, on that outcrop. Interestingly, since that research, there's been another unit found or documented between the Muave limestone and the Redwall, well, actually the overlying Temple Butte limestone. In the Grand Canyon, the sequence goes Muave, now the Frenchman Mountain Dollarstone, and then there's a time break, the Temple Butte limestone, and then the Redwall limestone. And on that particular outcrop, those units are missing. And so, as Douglas Sharp has indicated with his question, there appears to be this anomaly where there potentially is intertonguing between the Redwall and the underlying Muave on the North Kaibab Trail, and no one, as far as I know, has followed that up since. That was documented.
All right, thank you for that. So there are some questions in the chat regarding the claims on radiometric dating. So we know that there are many assumptions that are inherent, but how far off is radioactive decay? So is it like 10 per 1,000 to 1?
Well,
so someone is saying about the laws of physics. So they're equating the radiometric dating to the laws of physics. So how would you rebut to that?
We have evidence that was documented in the RATE project, several lines of evidence that at least during the flood and maybe at another time in Earth history, earlier in Earth history, the decay rates were accelerated by orders of magnitude. And so, for example, during the flood year, there would have been hundreds of millions of years worth of accelerated nuclear decay. We see there evidence of physical decay has occurred from the fission tracks and the radial halos, but we also find that the layers that equate to the beginning of the flood and the end of the flood, they have more or less quantities of radioactive decay recorded. We find disparity between different methods that indicate that the greater the atomic weight of the parent isotope, the greater is the acceleration. So there's lots of evidence. There's helium diffusion in zircons that we demonstrated. And so radiometric dating might expands the time scale, but the resulting ages are relative. And there are other problems. For example, in the literature, we have evidence of inheritance. So, for example, we know of within the mantle, there are geochemical reservoirs that have particular isotope ratios, so that when you have recent eruptions of recent lava flows on ocean islands,
Yes.
you get lead ages of 1 to 2 billion years.
Yes.
That's because of the source material, not because of the age of the basalts.
Right.
And so we see that kind of evidence. We find contamination is evident. And then, for example, if the decay rates were faster, then that means you can't use them accurately as a clock. You can only use them as a relative scale. So, for example, in the research I did on fission tracks, we looked at a volcanic ash bed at the bottom of the Grand Canyon. There was 500 million years worth of fission tracks. You go to the Colorado Plateau elsewhere, we find in the Morrison Formation ash beds that are 165 million years old. There was 165 million years old worth of fission tracks, and an ash bed at the very top of the Colorado Plateau that was only a couple of millions of years old. There was only very few fission tracks. And so even though they were at the beginning of the flood, middle of the flood, the end of the flood, there was this scaled relative radiometric ages because the younger sediments deposited during the flood would have experienced less radiometric decay. Now, here's an interesting point. I mentioned in the presentation that the Tapeats Sandstone was radiometrically dated using detrital zircons. In other words, they look at the source. The zircon grains come from erosion of the sources. The sand grains and the zircon grains were eroded from the sources of the Tapeats Sandstone. And so what they're looking for is the youngest source of zircons that is deposited in the Tapeats Sandstone. And when they published the result, they published result was 507 to 508 million years. But if you go to the raw data in the appendices to that paper, you will find that there were many grains that were a lot younger than 507 to 508 million years old. So why are there zircon grains that yield much younger uranium lead ages, zircon ages, in the sandstone if the sandstone is supposedly that old? It doesn't add up. So there are inconsistencies that are not explained. And those inconsistencies are because of things like contamination and factors like that. So there are lots of real problems with the radiometric dating methods. There's inheritance, there's contamination, there's accelerated decay rates. So we need to be careful how we interpret the radiometric dates published in the literature. And we need to look at a case-by-case examples in context.
Yeah, thank you very much for that. And I would encourage those who are asking the questions, look at other case studies like Mount St. Helens. But if you're in the field, you'll actually see, if you look closely, when they triangulate the methods, it's a lot of variation. The final question that I see here in the chat is about getting samples. I recall hearing that the first Trump administration made that field sampling possible. Is there still access for sample gathering there or in other areas?
Well, it depends. All the national parks allow for research to be done in them. And so properly credentialed researchers can apply. There is an application process, which I agree with, where you fill out the application, you put in a research proposal, your methods, you have to show where you want to sample, because they have to assess whether you're going to be sampling at, say, significant archaeological sites that need to be preserved, etc. And that has to go through a peer review process. And so if a creationist were to apply for a sampling and research permit in any national park, and that was application was rejected, then one could use my lawsuit as a precedent. In other words, if it could be demonstrated that your application was rejected because of worldview discrimination, then the Park Service has already been told it cannot discriminate according to worldviews. And of course, that is a standard procedure. It wasn't just in the first Trump administration. I believe it's also true in the second Trump administration. So it is possible for creationists to apply, any scientist to apply, and I'm happy for any scientist to apply, their worldview or not. I'm happy to see good research done in all the national parks, but it has to be done in a proper way with good methods, proper sampling protocols, etc., that doesn't harm archaeological sites or ecologically sensitive areas, etc. So, creationists need to do good science just like their conventional colleagues and be accountable for that research just like their conventional colleagues.
Okay, thank you for that, and thank you for responding so well to all the questions. I'd also love to thank the audience for being so lively tonight. So we definitely appreciate you, Dr. Snelling, and we appreciate you sharing your experiences in addition to your research and just encouraging you to continue being an inspiration. All right, so as we wrap up, I want to remind our audience that if you're watching, please visit our website, logosresearchassociates.org. And on this website, you will learn about the various research efforts that all of our associates and ambassadors do and find information about their publications. So if you look at the tab research, you'll also be able to donate. We're working on getting the super chats in, but please do share our channel as well on YouTube, because that will assist us to be able to be more efficient. And please take a few moments to also continue to browse our Facebook page as well. And if you have not yet subscribed to our email list, you can actually subscribe and receive notifications about our other upcoming presentations. So you can subscribe both on YouTube as well as to our email list at logosresearchassociates.org. And we want to let you know, maybe you did not tune in at the beginning of the presentation, but a recording of this video is available right now on YouTube. So you can share it with others who may not have been able to join us for tonight. So without further ado, I want to keep your attention knowing that we have an upcoming presentation. Our next presentation will be by Helmut Welk. He is an industrial engineer and also on the board of trustees for Logos Research Associates, as well as for the Institute for Industrial and Systems Engineers. He'll be presenting next month, God willing, second Wednesday, June 10, 2026, same time, on biblical cosmology, the first 4 days of creation. And so it's a presentation you definitely won't want to miss. As we close, as usual, we will close with a short prayer. And so if you join me, let's pray. Dear Heavenly Father, we thank you for this presentation. We thank you for those who tuned in, oh Lord, no matter what their background has been. We just ask that as we do our different endeavors in our different with our different skills, that we will pause and remember that life is finite and that our purpose in life is really to find the truth, which is you, O Lord. We just ask that you will help us to draw closer to the truth in whatever field of study we are in. And we thank you, Lord, for walking beside us. Be with each of us here and those around the world who are listening. And we thank you for all that you will continue to do. Bless Dr. Snelling and his family and all your people around the world. And may you continue to bless Logos Research Associates. In Jesus' holy and precious name, amen. All right, so thanks again for joining us, and see you next time, God willing.